Okay, let's talk about probability, the new unit. So, what is probability? Let's see. Probability. It's kind of like the math of chance. Basically, the probability of an event tells you how likely something will occur. Tells you how likely something will occur. Now, it's a math class, so the probability of an event is a number. The question is, how do we interpret this number? And that's what we give you prob and stats. It's your interpretation of number, but a probability is a number. Okay, so we need to define some terms. Outcome. An outcome is the result of a single trial. For example, the rolling of a die. Rolling of a die. Flipping a coin. Picking a marble. Okay, the sample space. The sample space is all the possible outcomes. All possible outcomes. Right? And the last word is an event. An event is an outcome or a group of outcomes. So I'm going to say, given that you rolled a die, what is the probability that the event of a 5 occurs? That's kind of the idea. Given I'm flipping a coin, that's the trial. I'm flipping a coin. What is the probability that you get heads? Okay. Now let's go through this. So, can you see the board? Yeah. I feel like it should be darker. Let me try a different color. Let's see. So I have a bag of marbles here, and I want a darker color. You have a bag of marbles. 3 are red, 2 are blue, and 5 are yellow. Can you see all the way over there? Yeah. So let's see. 3 are red, 2 are blue, 5 are yellow. So the event is picking a blue marble. Okay. The sample space is the possible outcomes. There's 3 reds, 2 blues, and 5 yellows, and we might want to say, there's 10 marbles. 10 marbles, and then let's say a favorable outcome. And let's say 2 blue. Picking a blue marble, picking 3 red, picking 1 blue and 1 yellow, picking, a black marble, something like that. Something that we hope will happen. Okay. Theoretical probability. Let's see. Theoretical probability. Let's see. Theoretical probability is a made-up scenario For example, all marbles have an equal chance of being picked. For example, there's no bag of marbles. That's not a real bag of marbles. I merely just said, I want you to imagine in your head, there's a bag of marbles, and there's 3 red, 2 blue, 5 yellow, And I want you to imagine that when I pick the marbles out, they all have an equal chance. So this is all in my head. This is all theoretical. So made up sense. So an example is all the marbles have an equal chance of being picked. Once again, it's we're creating the construct of what is going to happen. And so the probability of an event is equal to the number of favorable outcomes divided by, divided by the number of possible outcomes, or the number of elements in the sample space. The number of possible outcome. It's very straight. So for example, the probability of picking what? A blue marble. So how many favorable outcomes are there? There's 2 marbles, so it's 2. What's the problem? What is the number of possible outcomes? 10. 2 out of 10, 1/5. The probability of picking a blue marble is 1/5, or 20%. And we represent it as a fraction, right? So we're in a math class. Let's talk about these numbers actually. So probability this, probability that. What is the range of the numbers? Well, the probability of never going to happen, probability of never going to happen is 0. And what's the probability of absolute certainty? The probability of absolute certainty, well, it's either 100%, but if we write it as a fraction, this is 1, which means the probability of an event is between 0 and 1. So with probabilities, we're exploring all these numbers between 0 and 1. The months of, so here, I'm running out of ink again. Let's try another marker color. Let's try this example. The months are written on pieces of paper and put into a bowl and placed in a bowl. So let's see. I want the probability that the month chosen starts with a J. What is the probability that the month chosen starts with a J? So let's see so we know, so the answer is, we would write the probability that the month starts with a J is equal to 3/12. So let's just write this down, what's going on here. Let's see, this is the event. This apparently is the favorable outcome. And this is the sample space. Is that true? Well, let's see. I know there's 12 months. And let's see. January, February, March, April, May, June, July, August, September, October, November. Yeah, 3/10. Or 1/4. Or you could say there's a 25% chance that I'm going to pick a month that has J. Nice. Let's move on. Complements. Well, a compliment is something nice that you say to each other, but a compliment is also the outcomes not in the event. Sorry. Compliments are outcomes not in the event. Let's erase all this. So let's break this down. So let's see. Rolling a die. Rolling a die. Well, it's 1, 2, 3, 4, 5, 6. Outcomes for rolling even. That would be 2, 4, 6. The complement of rolling and even is 1, 3, 5. This is the event, and that's the complement. This is the event. This is not that event. Okay, and therefore the probability of an event plus the probability of not happening. What do you think? Well, it's 1. Well, either it happens or it doesn't happen. Either it rains or it doesn't rain. So if someone says, "What's the probability of rain?" Say, "Oh, there's a 30% chance of rain." Therefore, what's the probability it's not going to rain? That's 70%. Well, we could write this, or right? If we see the probability of E, right? Plus the probability of not E. This is another way of writing not E with a dash over it. Some books might write a bar over it, so it equals 1. Or we could say the probability of something not happening is equal to 1 minus the probability of it happening. Nice. The last thing I want to talk about before I move on is something called odds. Something called odds. We say, "Oh, what are the odds that something's going to happen?" The odds are not probability. The odds are a ratio of an event to the complement. So, let's talk about the odds. You're not going to be asked. I just want you to know it. What are the odds? The odds are a ratio that compares favorable to not favorable. Favorable outcome to not favorable outcome. So for example, let's say we had a wheel. Let's say we had a wheel that was broken up into 12 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whoops, sorry. Wheels, and imagine in my theoretical world, all of these are equal. And the question is, what is the probability of getting greater than or equal to 8? Well, the probability of getting greater than or equal to 8 is 1, 2, 3, 4, 5. So that's 5 over 12. But the odds of getting greater than 8 are 5 to 7. I don't think IB's asking this. It's not in the curriculum, but I know the word just, what are the odds of that happening? The odds are not probability. Last thing, theoretical, experimental probability. Experimental probability. It's simply probability based on repeated trials. It's like what you do, it's knowledge gained from your science class. And the idea is you would run an experiment like 50 times. And then based on that information, you would say, this is the probability. So it's probability based on repeated trials. So experimental probability of an event is equal to the number of times an event occurred over the number of times the experiment is done. So we're not making something in our head. We're literally like, I think an experiment is take water and stick it in the freezer. What does it shrink or does it expand? Or do this to a plant. What happens? 20 plants. What happens? That's the idea of creating probabilities based on experiments. So here's a question. Last question, and we're done with the unit. You own a skateboard shop. Let me erase this off. Let's see. You own a skateboard shop. Okay. And you look at 100 skateboards. And 93 have no defects. So what is the probability of defects? Now, what's the difference though? The difference here is you actually had skateboards in front of you. That's the idea. You actually own, this is really happening. And this is how you're going to develop your probability. So the answer here is 7/100, or the 7%. Once again, in this scenario, this actually happened. You own a skateboard shop. And that's the difference. Good.